technologies available, but also, as Keith said, using it respectfully and using it sensibly. So there's no point in diving into new technology and doing something wrong, as we said with AI at the start. So a bit more of an introduction. That's my background: surveying large infrastructure projects, measured building surveys, elevations, and progressing to laser scanning, which we all know very well, but still massive data sets, very clunky to get into. And usually you have to, up to now, have a powerful gaming PC to actually access and use sensibly. So all this wonderful data quite often is coming too late in a project and is too heavy or too complex to look at and use. And by the time we've gone from specifying elevations like that through to actually getting complex building information models, it's layers and layers of complexity and also very heavy data, complex to visualize. But if we have a look at one example, everybody knows static LiDAR. Hopefully most people in the room will know mobile mapping, but I have to put this example up. And if you want to look on the on BBC Country File, there's an example of this being used by the National Trust by my old company, Seven Partnership. Because this particular example just shows how you can get 5 minutes drive through town, real-time mobile mapping on the back of a vehicle. Since this was done, they're also able to, at driving speed, map the pipes underneath the surface of the tarmac. And the accuracy we're looking at is a few millimeters on a cross section side to side on the bridge, and it's picking up all the elevations as you go through. So this is 2014. So you can see how far we've come now to data, and that kind of data now is actually subject to AI, automatic pothole detection, automatic mapping, automatic taking away of cars in the scene. There's a lot of automation, but still we're only just getting to share that data nicely. Moving on very quickly, the ability, this is my own house. When we moved in, we figured out, we knew we had a well in the front of the porch, but it wasn't a well. It turned out that it was a tank. So the first thing we did was to use the BLK to go scanner and scan. And what you can see on the right-hand side is live data from the scanner actually scanning that tank as it's going on my mobile phone. So we're starting to get more access to the data in terms of you can see what you've got on screen there and then, you know you've got it in the field. And that again makes it easier to get very complicated information in nooks and crannies around a site. So never let anybody tell you that actually you can't get information down there, up there, above ceiling tiles, down in tanks. It's possible now if you're using the right tool for the job. And very quickly, as I say, this isn't about laser scanning, but I had to do a bit of an introduction. There's handheld kit with, as you'll see, hopefully with my mouse pointer up here, 360 camera on top, which allows you to very quickly walk around the site, use active LiDAR with a scanner like this FJD Triton, and it's taking 360 video at the same time as scanning, and it's using the video to colorize the scan cloud and enable very quick mapping. And if I quickly go on, if you go on from there, you get things like the Navis, which the NBI at Wolverhampton have, which again shows you what you've got, gets a trajectory around site. You've got confidence in your survey, and you can scan an awful lot of information in one go. And we've got some live examples of Navis if anybody wants to see those later. So what you can do in a day or 2 days with the Navis is what used to be taking maybe a week with a terrestrial laser scanner. And that's the kind of data you're getting from it. So the point of showing those was to give an introduction to high accuracy virtual tours. So if you can get that kind of Navis scan data very, very quickly, right at the start of a project, then you've got the ability to add information to it, add notes to it, add tender information to it, and measure from it. And I say measure from it because this is a quick screenshot of some windows open in Navis Ivy on Go. So the point of Navis, as an example, is it's high accuracy scanning down to a couple of centimeters, or even a centimeter if you do it well, but processed in the web and delivered almost next day. The processed data can be used in a web page and shared with non-technical people. So you can share it potentially with the right allowances for security with contractors at the start of a job to give them a level playing field to look at the site, to hopefully, and these are some of my key points, aggregate information in one place, georeference it against individual items in that scan. It's showing you 360 images, which we can see on the screen. And behind that is the complex scan data you can measure to the centimetre from. So we've got a virtual tour online, which I can access with my laptop. You don't need much training to actually use it or measure from it, and you've got high accuracy data. So we haven't extracted any plans or building information models yet. But if we've got that, then we can actually start sharing that information live and making use of it. POI is a good term to remember, points of interest, which is a little tag you can put within the 3D space, and then you can start adding PDFs, videos, instructions, manuals, safety information, levels of different information, or even live feedback from elements within the site, which we'll come to later. That's the high accuracy end, but it's always worth stressing at the low accuracy end on site, there's systems like this. This is VGIS, again, handheld. It scans very quickly. It's probably accurate to about 50 mil, but very quickly on site, you can get elements that have been dug up, covered up, and you can view them in position, in real time, in augmented reality, to a low level of accuracy, but good enough. So if somebody's got this kind of level of detail on site, then to be able to share that with contractors coming in and not just say, oh, well, there's some pipe somewhere in there, you need to deal with that, show them what they're dealing with. Again, digging a virtual pit, as they say on the screen, here's a great way of looking at that solution. And here's another example. This is from another company I've worked with called Jennings and Cook, and they're resellers for this bit of kit, which is the Kick the Map system. So again, mobile phone, scans straight to there, gets information in 3D, processes it on the phone, georeferences it, and allows you then to use more systems back in the office to see, to line up what 3D information we've got under the ground, compare that to the information on the ground and be able to visualize it on site, or do the basics of measuring areas, volumes, taking dimensions on site. Again, it's getting into the realms of being very quick, and if it's quick, it's cheap, it's fast, and it's lowering programs. And the last part of the laser scanning bit I wanted to show you was a couple of different systems, well, mainly Sensat. Up until a few years ago, you've got massive point clouds and big projects that I was working on in terms of infrastructure. They're very hard to share and collaborate with because everybody's on slightly different systems. Not everybody's got the high technology and the right license. But if you've got something like Sensat, then it allows survey data, point cloud data, images, mapping data, designs, all to be gathered in one place and used as a collaborative system to share on a project to aid communication. One of the main things for QSs must be communications in terms of, does everybody have the right knowledge? Does everybody have the right plans? Used to be terrible problems in my days of date stamped plans. Are we working from the right plan? No, it's an old plan, it's an old design. There's lots of systems for that, project-wise and large systems, but as an aggregator way to easily, non-technical, get hold of large areas of data streamed by the web into one place. And if you look very carefully again up here, the bar on the top of that little screen shows date stamps of data at different times. So we can show progress on the project. We can look back, we can see what's changed, we can take volumes and information from all of these elements and we can tag it. And then we can start having conversations about individual locations, not just about emails and data. So choosing the right weapon, there's lots of weapons to use. If you're unsure, just think, is there a better way of doing it? And if your workflows are at all what you were doing 5 or 10 years ago, then the answer will be there'll be a new way to do it, probably at less cost. But beware when you're procuring survey data and virtual tour data, people like to buy expensive bits of kit and use them to destruction. And it might be that if you've got some kit that you bought 10 years ago, it still works fine, but there might be a solution out there that does it now in half the time and half the cost or even less. So lots of different solutions for getting LiDAR data. But track new techniques, ask the question, have a look around, and ask somebody in QSI who knows if you're unsure. So that was the complicated high accuracy stuff. So now we're going to move straight into very, very straightforward, very cheap, but also very useful 360 imaging and 360 video. So it's an underused skill, and I used to have 5 or 6 of these that I'd encourage all the surveyors to take out. With a bit of kit like this is the 360 camera up here. They cost about £400 for a decent one. Battery can last 2 or 3 hours if you plug a cable onto it, and you can use it right at the start of a project or all the way through a project. If without even creating virtual tours or scanning anything, you can walk access routes, you can walk proposed routes, you can walk through a building, you can use it for site familiarization, you can share it with tenders. And the key thing about 360 video and images is you can pan around them. So if I look at a little bit of an example, oh, not that one. That's a 360 video of a dog on a hill. Forgot to put that one in. This one is a Historic England project. So the flax mill, the very first high-rise steel frame building in the world. Happens to be in Shrewsbury, my hometown. So we were asked to come in and do some virtual tour information at different stages through the project to give it back to Croft and English Heritage and let them share it with other people. Now, what you're seeing here is flicking through very quickly, but you can see the hand on the screen is just my mouse, and it's grabbing and moving around that image, front and back, left and right, as we go. So that's the first thing, is you can stop, you can pause that video, you can look at it, you can zoom in, you can look behind you, and you can get a very quick assessment of a very large area of site just by walking around it and sharing that video. There are tools in GIS that you can use to actually put a snail trail on a map. If the video is linked to your phone knows where its GPS is, then it's very easy to actually go through and track where, as a snail trail on a map, where that video was taken, and then jump back into individual parts of the video to see what it looks like there. So think about this in terms of sharing existing conditions. And if you take video, you can also take static images. And this is a quick program called Cooler, which allows you to take static images, put them into a base map, an image or a plan, and then start adding information around. So again, very quickly, we can add 360 images, other information, jump inside, maybe link it to a Matterport, and then share that on the web with other people. And if the cost is £400 for the kit, you're looking at the time it takes one person to go there. And with all these techniques, I think what to think about is the time for a junior person with very little experience to drive all the way to site, to capture 360 images, to rapid scan data or virtual tours is critical, really, because why send, I remember going to do a hospital in Brighton, why send 10 people to site to walk around and have the same tour briefing when really the person giving the briefing could walk around with a 360 camera, giving his briefing of what's where for a quotation right at the start of the project, and then send that out to everybody. And lots of people might not even need to go to site. Think of the transport costs and carbon used of 10, 20 people coming to site to view it. If we can share it as video, virtual tours, and have that as useful information, everybody's quoting from the same information. They've all got the same level of information. Nobody's taking 200 pictures each and holding them on their hard drives and then trying to make sense of where they were taken because they're all georeferenced. So it's a different way of working that potentially can get everybody knowing the same information, potentially better quoting because they can measure from it, and potentially more even quoting because everybody's got the same information and everybody's virtually been to site. Now, in terms of the march of technology, I was told a long time ago that photogrammetry would probably overtake, well, it was told me by a photogrammetrist. So he said photogrammetry will overtake laser scanning. It's just a matter of processing power. Now, this was 1995 when I was flying aerial images over quarries and dealing with an old school photogrammetrist who used to take images, put those images together, work out what the 3D position was from using photogrammetric techniques and bundle adjustments of the photos, and then send me back a 3D mesh and a plan. If you look at the technology we've just used for the 360 camera, and you take only that data, no LiDAR data at the moment, you can throw that into a massive algorithm, and some very clever bods have called it Gaussian splatting. It's a very fancy version of photogrammetry. Effectively, it's still doing a bundle adjustment. You're getting information on that site. You're having a 360 video or images or camera positions taken through a site, throw that into a Gaussian splatting algorithm, and what comes out is something like this. So you can see that live data. That's not an image or a nice video. It's effectively a screenshot of live data that you can move through in 3D space. And to show you how eloquent it is, I accessed it on my phone and started navigating around that 3D data on my phone. And a very quick explanation of what it's doing is that is not a 3D model, amazingly. Although you can view it in 3D, you can zoom around it. It's a bunch of splats, little oval shapes floating in 3D space that are rendered with a color and a location as you're looking in that direction. So in not creating a 3D model, you're creating a group of splats in 3D space, which when they merge together, they make it look like 3D. And they figured out that this is a much faster way to render, in other words, to view a 3D model or a 3D information. So instead of having a large 3D model hosted in the cloud and then pulled into your mobile phone, which takes forever, you're just viewing what you see in front of you. And you're just rendering that in these Gaussian splats, and it's a very quick and easy way to do it. And if you pay a little bit more attention to that and you combine a bit of laser scanning with Gaussian splats, then you get this level of data, which I think is absolutely outstanding. So this would have been a few hours on site. So a couple of points of scan data to give a dimension to all that information. So to give it something to lock the photos to. And then in programs like Newbegin and Gaussian splatting algorithms, they've combined the scan data and the splatting algorithm to give this fantastic 3D model. And in terms of inspection, internal and external, that's an amazing data set, which then could be shared live. And if we pause that and just prove the point, I'll just go through past the attic. So this is the same data that's running live in my web page. Okay, it's not been animated to be a video for a fancy LinkedIn post, but absolutely outstanding level of detail. And I'm going to come out of that so I don't kill my browser. And I'm just going to redo this one. So this is a similar example. They've thrown a drone up in the air, no scan data for this one. So to get information on this tower, they've flown a drone around it and then putting into a Gaussian splatting algorithm to get that information. So in terms of survey data, I would have been pleased with a few reflectorless 3D points to show the size and location and orientation of those. But what you can get nowadays, and critically remember, viewing a browser is absolutely outstanding. So we're going to flick back into here and we'll move on. So Matterport is a virtual tour platform. So it's combining together what we've seen so far. So what we've seen so far is virtual tour, and we've seen LiDAR data, and we've seen 360 images. So what Matterport is it's an active LiDAR scanner. This one's an older infrared version. You can see the pulses of infrared coming out there. And you take it, you set it up every 3 meters, or with the latest kit, every 8 meters, and you take an observation that takes 15 seconds to do. You log it in an iPad, you process it in the cloud overnight, and you end up with this. So what it's doing is it's taking 360 images. Behind those 360 images sit point cloud data, and that point cloud data is used to create a mesh, which is the mesh you see here. And that mesh gives us this kind of data. So this again is the flax mill. This was done in a single day, 8 stories. We took 360 images outside, and it was processed, took 2 days to process in the cloud, and it was delivered, scanned on the Monday, delivered Wednesday evening to Historic England. Now this is something that can then be used. You can change it by floor. You can just visualize a floor at a time. You can view it externally in what this is called the doll's house view, and you can go into it and you can measure from it. So this is primarily used in the UK for residential and commercial property sales, but underused in terms of information at the start of projects. And when I was working for Network Rail on projects, we do a large station survey, and every time when we suggested this to them, they would say, right, okay, the virtual Matterport tour goes into site and does that right at the start on day 1 of access to the site. And at the same time, as soon as the Matterport was done, they'd send the survey data in there to get the scans of the site and create the plans. But the critical thing about the Matterport data is it gave them a rough 3D model, accurate to within 2 or 3 centimeters, and it gave it them on day 4 of the project, not end of month 1 for the project. So they immediately had project information in 3D they could start measuring from, they could start using for health and safety briefs, all the good things you could use it for. And in terms of a virtual tour like this, we can add points of interest to it. We can embed it in Windows. We can look at external links in there. We can stream 360 video into it. We can use it for hazards, near misses, safety points, and we can actually start adding an awful lot of information to it. We can put key points and have those as a little persistent menu very easily to jump around into. And we can start adding plans and information into there as live data. And I'll skip past that one because it's just showing how you can view videos and photos. Now, as an example of what you can do, I've flipped into this one. So this is a Matterport tour. You can see we're looking at a 360 image there. And what you can see is I've turned on measurement mode. So you can take free measurements of anything you want. If you want to measure from the corner of there, Now, take it in mind, this is early access to information, giving you a rough idea. So rough idea, I mean a couple of centimeters would be about the right kind of accuracy within a room. You can get better than that, but that's roughly right. But it's also got this automated feature now, which has come over the last year or so, where it automatically does that for the main dimensions of the room, which you can hide or you can show. And because it's got 360 images inside and out, the latest scans, you can actually scan inside a building and outside the building. And one thing to really note as well is with the advent of intelligent AI and add-ons, you can actually turn off the measurements, but you could also remove the furniture with a function called defurnish. So you can start to play with this data a lot better and share it. And then if you go along to a client and you say, I want them to be looking at this dimension here, turn the furniture back on, in that direction, looking towards that portal, and you press U, you can copy a link to the clipboard, send that in an email, and they will take them directly to that view. Now, there's always going to be security allowances. Are you allowed to share the information? Is it password protected? Yes, you can put passwords on it. And I think now Matterport, which used to be hosted in the States, also has Matterport for government and other ways of actually securing that information to actually let only notified people see it. So let's flick back into presentation mode. So once we've got information like this that we can share through, again, this is done in about 3 hours on site. This was an old historic building. You've got to try and think, what would you use this for and how could you share it? And this 3D mesh information is available to download as OBJ files and then put into a different program. So if you wanted to give it to somebody technical who's got 3D access to programs more powerful than Matterport, you can give that mesh to them and they can start chopping and changing it, measuring it from it, looking at quantities. And it's exactly what I did on a very small job for the room I'm in now and the building I'm in now, the old stables. I spent 2 years doing a refurb project on it, and I used the mesh. I put a limit box around the mesh to give me a cross sections through the building, and use measurements on that to figure out where we were going to knock through walls, how we were going to get into loft spaces, where we're going to make double height ceilings. And to move on quickly, you can actually as well use drone and survey information and get that hosted on the web with programs called like Sketchfab, which then allow you to look through the external high accuracy information, tag it, add information to it, but also view that in context. If I look at an example here, if we've got a 3D plan or information around a site that we can seed information onto, then that allows us to do things like this. So if we've got multiple Matterports, so each little number on there is a different Matterport scan. We've taken 3D information, which could have just been a 2D plan, linked that to where each Matterport scan is on that site, and then just put little hot links to jump you into the Matterport scan. So that's combining two online solutions, Sketchfab for putting 3D external information to, and Matterport for putting the 3D internal information to. And that allows us to look at multiple sites within a university complex or estate, multiple sites within a town. If there's lots of different scan positions you need to know, you can pull them together in one area. Now, we're moving quite quickly, but hopefully you can see the thread of information. It's all viewed online and it's all easily accessible, easily used. Now, this was a great project, which I can share a link to as well, by eMaking. So it was created and it won an award for collaboration, because what it did was it took the central information of a Matterport scan, and probably better viewed if I jump into the online version, but it combined together Matterport information, building information models, M&E plans, roof plans, and 3D data. And it did that, I'll come out here, in this system. So again, you can see the Matterport information in the background. But then what they managed to do was create different Matterport models at different time stages and allow you access to that in a little window portal. But also give you access in the same system to building information model that could be streamed into that window and shared in the same place. So very cleverly, they allow anybody to look through different epochs in the building process, different data that's been gathered, put it all together in one place and give anybody a tour. So if you think how useful that is for sharing back with clients, for showing progress, for recording on a building, but also for starting to think about like the UK thing of the golden thread, which actually puts a thread of information through a project and allows you to start to aggregate information and keep it and share it and hold it. So that starts to make us think, okay, well, is that a digital twin? Is it a digital model? Is it just a digital data set? A quick informer for you in terms of what best way I've seen it explained. A digital model is just a scan or a model of a physical item. It doesn't do anything. It just exists in 3D. You can explore it. A digital shadow has information delivered to that model that's actually live data. So Matterport would be digital model, but if we had live information of temperature in a room, that would be digital shadow. And if that live information of temperature of a room actually actuated when it got to a certain temperature, it automatically opened a window, that would be a digital twin, because you've got an automatic flow of data which is affecting the physical from the digital. So that's a good way of explaining it. And the other thing we have to deal with coming up in construction projects is this golden thread of information, also linked to the building safety regulations, where you can keep information held all the way through a project. Now, we're running short of time, so I'm going to skip past this one very quickly, but think of live data within a virtual tour could be noise, dust, pollution, which have to be logged on sites now for nuisance and for regulatory purposes. Those can be live sensors like that, movement sensors, dust sensors, noise sensors, pollution sensors. The batteries will run for 2 or 3 years. The data goes up live to a website. You can put alerts on it, but also you can feed that data into your virtual tour. So I'll make these slides available at the end for anybody who wants, because I know I'm moving fairly quickly. We've got about 5 minutes left, so I'll flick through this. So if we can have live data delivered into a Matterport scan or a Navis scan or a different solution, that opens up a whole world of things we can do later on in the project. So we can not only do this at the start of the project if there's things that need to be delivered, but we can host that data that we scanned at the start. We can scan in different epochs and also use it at the end for facilities management by adding information to it. So think about that. And what I'll do as the last example is to show you a way that Matterport has been used as a platform by a company called SimLab, who I had a meeting with this year, to produce a couple of different solutions. One is Stages and one is Simon. Stages takes the Matterport scan. It has the Matterport 3D mesh behind it, but it also enables you to view the point cloud and the building information model and extracted 2D floor plans. So this is the kind of thing we can view on there. IFCs, PDFs, OBJ files, FBX files for 3D models, point clouds, and Matterport 360s. So we can aggregate all that information in a project, but what makes it really useful is we can then do that at different stages through the project. So Stages allows you to take a scan of a building on week 4, week 9, week 12, week 14, week 17, and keep them all in the same program, all evidenced, all with information when it's needed, added as points of interest referenced into those rooms and held in a database. And later on, that could also be used with a similar package called Simon, which allows you to add that live data feeds in and use it for facilities management. And it also allows us to do funky things if we want to, like add 3D information to a model. Well, that might be fun for marketing, but that also means we can add a 3D digger or a forklift truck on there. We can check, can something fit through a 3D space just by putting it in there in augmented reality or actually in the model. So we can start to play with the data in ways that used to take very complicated software to combine 3D information together, and you could almost do it yourself. It has integrations with something called Procore database, which hopefully you'll be more familiar than I will be, but it allows you to start using it as much more of a QS tool because we've got those date stamps of information and we've got them logged in a backend database against 3D locations. So to actually use this for construction management, asset management, and then maybe later on for IoT devices putting in, makes it a useful tool. And in their words, this is the kind of benefits they're getting from it. So decreasing in-person site visits from stakeholders, which we've already talked about, by 50%. I think that could even be a lot more in lots of cases. 75% visibility of intelligence information by live data. Lots of ways to actually reduce the time spent on site, the time site surveying reduced by 70%, and if you're reducing time on site, you're reducing risk and you're reducing program and you're reducing cost. So we've done a quick run through. I wanted to try and be 45 minutes. So we've looked at vehicle-based mobile mapping, just to show you what you can do in a short time. Rapid Accurate SLAM, which was Navis, which you can see examples of at the NBI. Handheld SLAM, Kick the Map was a good system from Jennings and Cook. 360 video We've looked at 360 images and how you can just put those into an online tour, Cooler being the easiest, simplest and cheapest. You're looking at about, I think, £40 or maybe even £30 a month for Cooler. 3D splats is a way to visualize 3D data and share them with people. And the examples I showed you of the tower and the windmill mean that if you add a little bit of scan data to that, you can combine those splats into a 3D model that is georeferenced and measurable and accurate. 3D tours, Matterports, again, which I've done and NBI have done. Hybrid tours, which is the e-making example of combining BIM and virtual tours. And lastly, we've looked at SimLab stages, which gets you the ability to look at information going all the way through a project. And as a little example, I've got a project here. So we've looked, this one has been scanned 3 different times. So second scan halfway through the project versus the final scan. And if the web connection hasn't been killed by my other work, effectively what it does is it jumps into location that it can find in both scans, and it shows you them in Windows parallel. So you can start to see on a finished scan, you know, what was above the ceiling, what's first fix, second fix, where's the M&E plant, what's been done. You could share this to show progress with the client. And if I look in this one, we've got 11 stages. So we can pick up here, we can say, okay, let's have stage 4 in this one and stage 10 in that one. And if I turn that off, it should align. And we can start to see there was a partition there. This was the original, kind of as knocked out positions. And then further down the project, when you can see it's been fitted out, you've got a way of doing. And all these are measurable, and you can put plans behind it, and you can start collaborating, saying this needs to be done, this is a snagging element. So that whole point of, can you use it for pre-existing contracts, existing conditions, interim valuations, snagging and defecting, handover, and even post project analysis, means that you've got something a lot more useful. So I would encourage everybody to explore, just ask the question. We've seen an awful lot there. If I can answer a question at the end, we'll go for it. But some takeaways: think about democratizing access to that 3D data because other people can use it. Think about tagging and geotagging points within that 3D space, so you're relating information through to an actual physical 3D space. Think about moving towards digital twins and what they actually are and what they aren't. Think about 360 images and video. Can you use them? Preserve site details and timelines, cut visits for quotations, and leverage that information that you've gathered for QS teams to pass it on and use it for safety. Use it for briefings, use it for marketing, use it for FM. So that's a very quick run through of what we've looked at. I will flick out of my presentation mode and hopefully jump back into everybody view. Right. So yeah, that's me done. And if I go back one, then I can stop that video. No, that's fine. I managed to do that without going hoarse. So
yes, well done, well done. It was, yes, it was a real romp through, wasn't it? A lot of technology.
It was a romp
there.
through. I wanted to put a lot of information in there in a short time, but I wanted to give people a flavour of what you can do and hopefully find some useful points from it.
Yeah, a great overview of leading technology.
Oh, thanks.
Okay, so does anyone have any questions for Nick? Shout out, put your hand up, write something in the chat. Oh, there we go, Keith. Thank you.
Yeah, we're hoping that everybody's not the wiser but better informed. Thank you.
I'd agree with that.
Way of putting it, none the wiser but better informed. No, I think it's absolutely amazing. I mean, I'm old enough to go back pre-computer days, but anyway,
yes.
No.
Yeah, no, I was pen plotters when I started, Keith, and hand-drawn sketches.
Yes, that's good. Yes. when you looking at the one of the early ones where you're doing the road, you say drive down the
Yes.
road, but you can now plot what's under the ground as well.
Yes.
How? What does it use?
Okay.
Radar or what?
So I'm still showing the screen, so I'm going to quickly whip back. Let's have a look. Yeah, it's easier just to press the button than to figure out how to change my screen sharing. The answer, while I'm scrolling back, I'll show you the physical picture of it, is above the ground, it's LiDAR, and beneath the ground, it's ground penetrating radar, so GPR. So what you've got is simultaneously, nearly there. Where is he? Yeah, simultaneously, you're scanning above ground.
Yeah.
There we go. So what you see there is the scanner above ground. That's the LiDAR. And it's got a 360 camera and a GPS.
Oh, right. Yes.
And
Yeah.
an inertial navigation system. So it's like a missile. It knows where it's going through 3D space. It knows where it is, and then it tracks where it's going with the inertial system. And that location information, it knows physically where this is, which is the ground penetrating radar, because it's a fixed location relative to the scanner above. So
Yep.
this gets its location, and once it's got its location, it's shooting down ground penetrating radar beams into the ground on an array of 4 different sensors in different directions. So in real time, it's going through and scanning below the ground and above, and then you can combine those 2 different data sets because they're both on the same grid together in one visualization. So you basically get them both in building information package or wherever as one point cloud, which then you've got to make sense of with ground penetrating radar. But no, it's funky stuff, that is.
It is. But presumably then, if all this is done in the cloud, this is done at the sort of the data centers.
Well, so there's 2 different things there. One is the processing of that very heavy data is still done locally on a laptop. And once we've got all that data, then we can use programs like Sensat to aggregate it and upload it into the cloud. And, if you think about it, you've got to then justify the return on investment, because if you willy-nilly put everything into the cloud and say, pat yourself on the back that you've saved 50 site visits on that project, then you might have burnt so many thousand litres of fossil fuel in powering the data centers to host that information. So there's a cut and thrust on it. But yeah, the principle is you can get that scan data now and you can host it in the cloud and get access to it if you need to.
This is why data centers are developing all the time and are so huge and take so much information.
Yeah, but it's also why things like Gaussian splatting is good, because it lowers the level of information you need to host and stream and issues it very quickly to the computer. So it doesn't need massive processing power to host or to stream and view. So the algorithms are making it better, for sure.
Thank you very much. Absolutely fascinating talk.
Nick, we have a question in the chat. Shall I read it out?
Yes, no, if you could, please.
From Paul. Thank you, Paul. I work in a company that does surveys of sub-suspended floor space in limited space cavity spaces. We need information for the purpose of evaluating if the property is suitable for the installation of underfloor insulation. How can we use this tech to build a 360 imaging scan in that environment?
Okay, well, if you're allowed to get slightly invasive on it and you can actually physically get access to a core hole or a lifted floorboard or a suspended panel that lets you see underneath, then there's a way to scan. So you can either put a small scanner down like the handheld one I had of my manhole, and you can scan beneath to actually see the space. Or you can put very small cameras through, which we use for confined spaces, which have some scanning ability, and you basically poke them through into a hole. It's a very specialized thing because it usually comes with the mining projects that are done in adit shafts, and you can put your scanner and visualizing kit through and scan behind into a confined space. So you've got to have line of sight once you've put your gadget through, whichever that gadget is, but you can light it, so you can take 360 images. You can have specialist scanners that go through a small hole into a space to scan the space behind. So there are ways of doing it. It's not as easy as walking through with a Matterport and just going point every 8 meters and then upload it and put it in a virtual tour. But you can still use elements like Cooler to put a 360 camera through and a lighting rig, take an image. The little camera I showed you has a self-leveling mechanism. So if you saw it up on my backpack sitting up behind me, if I turned it upside down and put it through a hole and the hole was lit, then that would take a 360 image, but the self-leveling mechanism within that little camera will mean that the image is then righted. So what you're seeing as a 360 image under the floorboards rights itself, and it's correctly viewed with the right orientation. If you press the camera calibration button before you take the image. So yeah, there's ways of doing it. The specific way of doing it, you'd need to have a look at that specific site and see if you need £20,000 worth of kit or £200 worth of kit. But there's usually a way of doing it if you try hard enough.
Hope that helps, Paul. Anyone else got any questions before we close? It's all gone quiet. Okay.
Yeah, that's fine. Well, I will, if anybody has need to ask any questions right at the end, if I just pull up PowerPoint again, come out of there. So they can contact me with my email, which is nick@nsb3d.xyz. And maybe you can make that available to everybody afterwards, Suzanne, if they need to.
Yes, certainly. Yeah.
Or you can find me on the internet via NSB3D, and I'll happily answer any questions if I can. So you can always find me through the QSI network for sure.
Okay. Nick, I apologise for putting you on the spot here because I should have asked you this previously, but are you happy for your slides to be circulated?
Yes, I've taken away anything that's vaguely sensitive and military, nuclear, and so there's most of the examples are there. So I will make them available. I'll send them to yourself, Suzanne.
Please, that would be lovely. So
they've been pre-sanitized, so I'm happy to do that.
Wonderful. That's what we like. Thank you. So yes, if anyone would like a copy of Nick's slides or you'd like a CPD certificate, as always, just message in the chat now or send me an email and I'll sort that out for you.
And
so it just remains
I thought might be useful. Oh, sorry, Suzanne. One more thing that was useful. I've shared a link to all the live examples that I showed. I have the web link too, so everybody can try those live examples.
Ah, okay. Yep.
So I'll share them with you again.
That's great. Thank you very much. So yes, just to say thank you, Nick, for a really interesting presentation. I think you've given us all a lot to think about there. Our next First Thursday Club, just to do a bit of advertising here, is the 2nd of October. We'll have Nigel Barr back with us by popular demand. This time he's talking about warranties, bonds and guarantees. So as always, information will be going out about that on the email probably early next week. So look out for that and we hope to see you all again soon. Thank you very much.
Brilliant. Okay, thanks, Suzanne.
Okay, thank you, Nick. Much appreciated.
Great talk, Nick. Well done.
See you soon. Bye. Bye, everyone.